Hey y'all, welcome back to the lab. In this video, we're going to be talking about the advent of Code 2024 and really solving problem 1 with F#. Now, we're going to show the full source code and I'm going to be running it to prove to you that this works. But if you want the full project source code so you can just download it and run it yourself, that's available here in my code examples repo, which is available to Haminians members. You can join for $2 a month. It helps me out and it helps me create more videos like this. Okay, so on to the question itself. So the ways these work are they're split into part 1 and part 2, and I usually try to solve these independently because part 2 usually throws a wrench into everything, and so it ends up being its own solution, and so we'll go through it that way here as well. So here's the full prompt. You can get it at adventofcode.com. And it's kind of long, so I'm not going to go ahead and read it, but if you want the full thing, you can just come over here and read it. Instead, we'll just jump ahead to the takeaways that I got from it. And usually I do this in interviewing questions, and when I'm trying to solve a particular problem, is kind of write out the strategy that we're going to use before we jump into code. And so basically what we're given is a list of location IDs, and we're going to have a left list and a right list. And in my case, there was 1,000 of them, but we can imagine that there's a lot of these. And the ask basically is to match the location ID ordinalities. So this would be the 0th in the left list with the 0th in the right list, the first in the left with the first in the right, etc. Find the differences between these and then sum the differences. And so the solution that I came up with this is to basically do a simple order by and sum. And so this would cost us about O of n log n plus 2n with 2n of memory, which is pretty reasonable, all things considered. And so basically the approach we can take is to just parse out all values from left and right list. This will take O of n space here. And then we can sort each in ascending with just a simple sort. And the reason we do this is so that we can make sure that we're matching up the ordinalities with the simple index. And this will allow us to just do a simple index for loop over the sorted list to sum the differences. And so the solution code is here. If you want to take a look at it, copy paste it, whatever, but we'll also look at it in my IDE so we get a little bit of syntax highlighting. Okay, so here we are in my HAMY Labs example repo. I'm inside my AOC base for 2024, and we can see here's the description of what I just showed you. We're in a problem 1 module, and here is the solution to part 1. So the first thing we got to do is actually get the data out. And so basically this is what the input looks like. It's just a large list of a bunch of numbers separated by a few spaces. And so I have this in a static folder in my project repo. And then in my FS proj, I'm including this content directly so that it's available in our code. And then in the actual solution, I'm reading this out by getting the executing directory, looking in the static folder, and getting the file out itself. And so that's how I'm inputting the inputs into my code. You could probably use just a raw string and just dump it in here, but I just wanted to use a file because it seemed a little bit better organized. And so here we get the executing directory, then we create the file path using path.combine, just to make sure that the slashes and stuff are correct. And then we're reading out all the lines. We're just doing file.readLines. This does lazy read, I believe. This is an IEnumerable, so this shouldn't matter too much if this file is super huge because we're not enumerating it directly. Although if there's only 1,000 lines, it's really not that much data, so it doesn't matter. Then we print this out just to show that this is running, and also to sanity check, are we getting all of the data out? And we see that we have 1,000 locations here. The next thing we need to do is turn this into actually reasonable data to process. We know what we care about is left list, right list, but it's actually just in one giant list. And so what we do first is we separate these out. And so basically what we're doing is we're mapping over each line, and then in each line we're splitting it by space. This is okay, but this will lead to a lot of null empty entries because it's actually 3 spaces. And so here we're filtering out the ones that are null or white space. We're saying only keep the ones that are not null or white space. And then we're just asserting here that there's 2 to make sure that this actually works. This works. And then we're returning this as a tuple of left and right. The reason we do a tuple is because then we can use this fancy unzip function, which will take the first and second items of the tuple and split those into their own lists. I've never used this before, but it was a pretty nice feature. And so that's how we're getting left list and right list here based on the lines in the file. We then know that we need to sort these lists in order to get the ordinalities to match up so that we can iterate through them by index. And so we simply sort these left list sorted, right list sorted. Is this a waste of space? Sure, because we're not doing it in place, but often I think readability trumps, quote unquote performance until it's an issue. And so we're just creating a new variable for this. We're just asserting that these are the same length just to make sure that nothing crazy happened up above. And then we actually have to find the total differences. And so what we're doing here is basically creating a range from 0 to the length of our list minus 1. This is an inclusive, so that's why we have to do that. And then we're going to iterate over the sequence with the index so that at every index we can get the left value and right value, calculate the difference. The absolute difference is what matters here. My first answer was wrong, so we needed the absolute here. And then we can add it to a total difference. This is a little bit imperative. There's probably another way we could do this where we create a list of all differences and then we sum them up, and that would probably be a little bit more functional, but this works fine here as well. Then finally, I'm just printing out the answer here and returning it in case we want to use it, but I'm just running this in a test, so we're not really using the answer. And we can see here that the total difference is this, and this was accepted for my problem input. And you can see my answer here, but remember that, everyone's input is different. I believe hashed on their user ID, and so your input will be different, and so this means your answer will probably be different as well. Okay, so on to part 2. So when I plugged this in, it said I got the right answer and it unlocked part 2. Part 2 again is available at this link, and it's here and it's pretty big. So if you want the full text, you can look at it here, but we'll just go over into my takeaways. So here's my description of the problem. So basically they're giving us the list of location IDs, that same list that we used as input in the first time. But now what they're asking us to do is to calculate the similarity score, which is basically add up the number in the left list after multiplying it by the number of times it appears in the right list. So basically they want you to have calculated the number of times a location ID appears in the right list, and then every time you see something in the left list, you're going to sum up that multiplied by the right list frequency. And so the solution here is really to just calculate the frequency in the right list and then start summing from the left. Pretty straightforward. So we can calculate the right frequency by just, iterating over the values and keeping a frequency dict, pretty common operation in like LeetCode code and stuff. You can do this in O of n, and then we iterate over the left values in O of n, and then we basically say, if it's not in the frequency list, then we give it a 0, but if it is, then it's val times frequency, and then we just sum over all of these values. Here's the code if you want to look at it, but again, we'll look at it in the IDE for some syntax highlighting. Okay, so here's the description I just showed you, and then here is my solve part 2. And so we're doing the same parsing of the exact same input and stuff. So basically all of this is the exact same. We're splitting it out into left list and right list. But then the operations on these values is what changes for part 2. So the first thing we do is we create this ID to frequency lookup. And here I'm actually using seek.countBy. I'm using ID, or I guess the value, as the key. And then we just turn this into a dict. And so we can see here that this count by actually returns us a sequence of a tuple of the key to the count. And so we're turning it into a dict, so we actually get that O of 1 lookup afterwards. After that, we've got to calculate total value. And this is basically a simple accumulation. So I wanted to try the seek.fold thing. And so what we're doing here is basically it takes in an accumulator, which is, the values up to this point, and then it's going to take in the current value that it's iterating on from the input list or sequence. Here we know that we're iterating over left list, so it'll be just whatever the current value is, which is the left ID. We're starting the accumulator at 0 because, this is a total sum. And so basically for the first item, it'll be, 0 goes in here, and then whatever the first value from left list is here. And now for each of these location IDs, we need to actually figure out what is the new value here. And so first we're going to try to figure out the multiplier, and the multiplier really is just, whatever's in the right list. And so we're looking this up. We're going to try to get value out to see if our location ID is in this. And if it is, then we pull out the frequency there and we return the frequency as the multiplier because it's, location ID times the number of times it was seen in the right list. And if we don't see it, then we return 0 because we want the multiplier to be 0. And then finally what we do is we return the accumulator, so whatever the current total is, plus left ID times multiplier. So if it existed, this would be ID times frequency, but if it doesn't exist, it would just be 0, which is what we want. And so this will run it over the entire list, folding this. We get the total value back, and then we just print it out here. My value was here, and the website accepted this, so it seems like it worked all right. Next, so overall this one wasn't so hard, which is good. if the first one's hard, like people rarely go to the other ones, but Advent of Code usually will get more and more hard as the days goes on. But even though this is like a pretty straightforward, I'd say this is probably like Elite Code Easy or something like that. I did get to try out some F# built-ins that I haven't really touched before. So things like count by, unzip, and fold. I've never really had a use case for this, but it was a pretty good use case drop-in for these. So I'm excited to use F# for more in the future. Now this year I'm going to try to keep up with AOC. Usually I get like the first couple and then I start falling off and I'm behind by a few days. But I'm going to try to keep up with it this year, and I'll be posting my full code and answers here and doing walkthroughs and stuff as well. Now if you want the full project source code, obviously the solutions are here, but you can also get the full project files and stuff here in my example repo, which is available to Hominions members here. If you like this post, you might also like how popular is F# in 2024. You might also be interested in a brief comparison of modern programming languages, TypeScript versus Golang versus Elixir versus Rust versus F#, and finally, how to build a full stack web app with F#, compiling a bunch of resources that I've written over the past few years to kind of get you from nothing to, full working web server. So that's it for this video. Thanks for watching, and I'll see you in the next one.